allows you to move one unit relative to the other. There are gears, belts, and chains, and this allows transmission of power from one part to another unit. You also have clutches and brakes. This allows connections between two parts of the frame and seals the O-rings. This allows, when you use seals, you have fluids, so this allows you to reduce the flow of fluid from one part to another part. You also have fasteners, the screws and nuts and bolts, frame together, connect together two different parts. And lastly, you have the shaft. If you look at the gearbox that is being passed around, you see that a lot of these components, they are located in a central cylinder. That cylinder that rotates is called the shaft. So what is your task? Your task as a designer when you deal with machine elements is you have to determine the motion. You have to determine the motion, the force, or any changes in energy. Why do you do this? Because you need to determine, you have to select material, you have to select the parts. You also have to select manufacturing processes. So you need to do this calculation so that you are able to select parts that you want, size that you want, manufacturing process that you want. And once you get this, you have to ensure that your prototype or your product works by studying your stresses, deflections, temperature changes, corrosion, and also dynamics, so vibration. So in this module, we don't talk so much about dynamics. Spend more time on the processes and deflections. Okay, your project. Your task in this module is to make the gearbox. You see a gearbox that pass around. What is a gearbox? A gearbox is a device to transmit power. And basically, it's trying to transmit power from what? Basically a source, normally the source to your output. And the gearbox, what it's trying to do is to change either the force or the torque or direction of motion. Okay, so your gearbox will consist of a gear arrangement, so you're not looking at belts or chains, you'll be working with gears. You see the gearbox that will be passed around. It will consist of gears to change the torque and speed. This module will focus on torque and speed, will not change the direction. Although it's possible to change the direction. If you look at this gearbox, you have this one as an input, that is an output, so it's 90 degrees change in direction. The gearbox, you see the two shafts here. One is connected to your input, most likely your motor. The other is connected to your output, whenever that you want to try. Okay, if you look at the gearbox, what kind of elements will it contain? Your gears, you can see from the gearbox that we pass around. Your gears will be located along the shaft. Okay, the shaft is the central cylinder that rotates. The shaft has to rotate relative to the housing, so you need bearings. And you also have the housing to house this. Okay, just a brief introduction of motors. Why do we need a gearbox? Normally, because motors that we buy, okay, so this is a motor. The motors that we buy, okay, normally they like to operate high speed but low torque. Naturally, they want to speed very fast, but they don't have a lot of torque. They cannot drive a lot of things. So normally what we do is we attach a gearbox to the gearhead, increase the torque, reduce the speed. Okay, so we want to be able to achieve a torque drive, but at the same time we are reducing the speed. And therefore, property of the gearbox will be what is called the gear ratio. The gear ratio is given by either by a ratio like this. A is a number, okay, 8 to 1, or simply we just say the gear ratio is A. Gear ratio is 5 to 10. So for example, if a gear ratio of 5, that means that if the motor input is 1000 RPM, okay, when you switch on, the motor is spinning at 2000 RPM. If you attach the gearbox to it, the gearbox has a gear ratio of 5, that means the speed is reduced by 5. The speed is reduced by 5, and the torque is increased by 5 times. So that's what the gear ratio does. If you look at the calculations, so the output speed is equal to your motor speed divided by your gear ratio. So your speed will decrease. Your output torque is given by the torque from the motor times the gear ratio. But this thing, the gearbox is not necessarily efficient, so we also have a term relating to the efficiency of the gearbox. So actually output torque is less than this theoretical number of your torque times gear ratio. Okay, if you look at commercially available gearboxes, gearheads, this is from Panasonic. They have gears of different types and different gear ratios. These are different gear ratios. So 3 to 200. You can see these numbers are the efficiency. So you can see they range from quite low, relatively quite high, the range of 50%. And a gearbox or gearhead has another property. This is in terms of the direction. So we are only looking at parallel. In this module, we look at parallel, but we are only looking at parallel gearboxes and also allow you to have right angles. So we look at the first case, you have parallel line. So what this means is that you have an input. Okay, this is connected to your motor. Your output shaft is not only parallel, but if it is parallel in like this, it shares the same axis. So basically you can draw the same axis across the input shaft and the output shaft. You can also have parallel offset, which means the two shafts are parallel, but the output shaft may be moved relative to your input shaft. So they are both parallel, but they are no longer in the same line. The lines are parallel, but they are no longer in the same line. You can also have right angles, whereby basically the input shaft is here and the output shaft is 90 degrees. Okay, so I said the project is designed to make the test gearhead. Your gearhead must fit to this. Okay, so this is the motor. This is the controller for the motor. You see at the back. Your gearhead has to be attached to this bracket, and it has to be connected to the output shaft of the motor. Okay, the motor has an output shaft. It has to be connected to this. The casing, the housing has to be connected to this bracket. This is one example of last year's work. Okay, so you are involved in the design. First, you have to figure out how many gears you need. You have to figure out the shafts, what's the size, what's the shape. You have to figure out the casing, you have to select the gears, you have to select the bearings. And then you have to draw, have a bill of material, listing your parts, deposit it, send it to the workshop. In the workshop, you have to look for yourself. Fabricators, you have to look for yourself. Okay, so that will be also an experience for you to contact different contractors, make sure that they do what you want them to do. So the result is something like this. And this is also one example of last year's work. It's not the best, but you have an idea of what it is. Thank you. So for your project brief, you are supposed to design a gearhead or gearbox. As I said, you have to be coupled with the given motor shaft. And you're going to use spur gears. There are different types of gears. You're going to use spur gears. The efficiency has to be 70%, and you must be able to measure. So you need to come up with a way to measure the torque. Okay, last year we didn't emphasize on this, so the students didn't manage to measure this year, I would like you really to be able to measure the speed. Okay, basically you're testing your machine and you're giving the specifications of the machine. So when you design this, don't just look at the gearbox, also figure out how you're going to measure the output of it. Basically measure the speed. Speed is quite easy, you use a micrometer. The torque is the one that is because the torque measure is only as much as expensive. So can you think of a way of measuring without doing that? There are three options. Okay, last year was quite simple. We only set 15 to 1 throughout or every group. But this year, we would like to have a few options and you're free to choose. Okay? So the first option is 20 to 1, the gear ratio. Your alignment of your output shaft should be parallel in line. So basically the output shaft and the input shaft should be the same line. And the rotational direction of the output shaft should be the same as your input shaft. So the direction that the motor spins is the direction of your output shaft of the gearbox. Option B, gear reduction ratio of 30 to 1. In this case, your alignment of output shaft is parallel and it will be offset. So you have choice offset it. But the rotational direction has to be opposite. The motor is driving one way, your output shaft should be driving the other way. It's the rotational direction. Option C is a 40 to 1 reduction ratio. Again, the alignment is parallel, offset, rotational direction same as the motor. And you are free to choose this. Other specifications, your gearbox has to be closed. So you have to think about lubrication because the gears will require lubrication. So you have to figure out how you can do that. You need, as I say, you need your solid casing, you need your housing to be attached to the bracket, to this bracket, plus the motor shaft. And one side of this has to be transparent. Most of your signals actually need to be transparent parts on the sides. I always tell them, if this is something that's spinning breaks, the broken part will fly off in one direction. In one plane of say. If this is spinning, if something breaks, the part will always fly in that direction. So if you put your transparent part here, this is the biggest part. If something breaks, it will definitely break the transparent part, and it may also cause injuries because this thing will break easily. Broken parts will fly off. So I always advise. Either this side or this side. So I would advise you to put the transparent part on this side and this side. Basically, not a lot of plate is perpendicular to the rotation of the shaft. Okay, because when something breaks, it only flies off this way. It doesn't fly off this way. You have a budget of $500. I think last year the average cost was about $350. This year I think you're going to need more parts, so hopefully $500 will be sufficient for you. Speed measurements, I think we go up to, I think actually should be about 3,000 per year in terms of the motor speed. You also have to estimate the life expectancy of your. Any questions? Any questions so far? Okay, this is most likely what you're going to do, okay? So first, obviously you need to understand the specifications. There may be some quick information here and there. And then the first step is to look at the gear, look at the gear arrangement. Because you want to achieve this kind of reduction ratios, you have to do some calculations, how to do this. So most likely, one pair of gear will not be sufficient. You're going to need 2 or 3 pairs of gears. That is where the complication comes in. And then once you get your gear, you have to calculate the size of your shaft. Because every gear has a inner ball that fits the gear to your shaft. And the shaft, you have to make sure that it doesn't break. Because if you select too small a size, then it will break. So you have to do calculations of your shaft. And once you determine the minimum size of your shaft, then you can start thinking about the bearing, selecting the bearing, to make sure that the bearing fits your shaft. And most likely your casing design will come in perhaps at this stage also, because you have to think about, if you think about your gear arrangement, you're looking whether it can fit in this bracket or not. You probably have to also think about your casing already, because the envelope of your gears may have to be extended, because otherwise it cannot fit this casing or this bracket. Then you have to think about your top. Basically, your top comes at the top shaft, your gearbox. Think how to measure it. And then you have to make a proper engineering drawing with tolerances. You see that when you select bearings, for example, you need to figure out the tolerances. And then you order the parts. They send it to the contractor. I was hoping that you assemble the different components yourself, but most likely you're much smarter than me. Just ask the contractor to assemble for you. That's what happened last time. Of course, there are pros and cons. Cons is one group realized that the contractor did a mistake, so they were late in submitting their prototype. So there are pros and cons to this. And then you have to test the efficiency of the gear. Okay, this is what I suggest. I think there are about 68 of you. The last class list that I received, I suggest you break into 10 groups. Each group will have 6 to 7 members. Now 6 to 7 members is quite a lot. Okay, so I hope that there won't be a lot of sleepers in your group. I would suggest something like this. May not necessarily be the case that one group or some of you within the group, maybe 2 of you will look at gears, 2 will look at shafts, 2 will look at housing, 2 will look at bearings, 2 will look at top management. Now this, you cannot work independently, okay? When you select the gears, you have to think about housing. Housing needs information from the gear. When you do your gears, you also have to speak with the shaft. The shaft needs information from the gears. Bearings and gears maybe can be separate. The bearings also need information from the shaft. It needs to feed information to the housing. And then all of you will generate the drawings. Maybe some of you are very good at SolidWorks. And also maybe one thing, this one also may be independent. You have to figure out how to measure the top. So within a group, you may want to delegate, okay, but it's up to you how to delegate. The grouping, I'll leave it to you. Is that okay? I'll leave it to you to select a group. So by default, please choose 7 in a group. I think maybe 2 teams will have 6. By default, please choose 7. Okay, one last thing. When we talk about machine elements, unless you are the gear designer, unless you are the bearing designer, we do not design the gears nor the bearings. Okay, what we normally do is we go to the workshop, we see what is available. So a principle, okay, when we design machines is that we will use standard stock sizes. So for example, if you're going to design your shaft, you find that you need a 53mm shaft. Okay, you'll see whether you have 50 or most likely 60mm bar or cylinder, so that you can machine it down to 53. So this is your standard. This is your standard bar. You will not necessarily choose something that is out, that's strange. Again, also for bearings and fasteners and gears, we will refer to catalogs. There's a catalog of gears in the FIP room. You don't have to use it, but it's already in the FIP room, so you can use it. That gear catalog is from KHK. And also, if you have any questions, it's useful to speak directly to the vendors or the specialists in those areas. So if you want to know more about bearings, SKF is a very big name in bearings, although whether or not they will entertain you, I'm not sure. But for gears, definitely you have a KHK catalog, you can speak to the guys. Okay? So you want to read textbooks. These are 2 recommended textbooks. One is by Charles, Mechanical Design Engineering. The other is Shixi, Mechanical Engineering Design, and Budinas and Ismet. questions? So when can you give me your grouping? Okay, for those who are late, as I said, I'm going to change the venue to SR5B. So in future, we're going to go to SR5B for both the lecture and also the studio, because it will be a one-shot, 3 hours activity. For today, I was thinking of playing a game, okay? Just to kickstart the module. I would suggest we head to SR5B. SR5B, okay? Now I've been told that the class may not be ready. I don't know what happened there. Maybe the chairs are everywhere. So you can just organize yourself. So we're going to play a game. You don't necessarily need a table, but it would be useful to have a table in front of you so that you can do things to it. Okay, so if you have no more questions, I suggest between now and arriving at SR5B, please decide on your grouping. When we are at SR5B, we will separate into the different groupings and we will do the activity. Okay, so I'll see you at SR5B.